So the third problem was a homework problem for you. You can just note down here. So you are given an acceleration as function of time, which is not constant, it's varying. So you know now this is most generic case, right? So you are given that variation of acceleration as function of time. It's function of time. And it's given by one single equation, so it's a continuous motion. So what is that? It's given as at t equals 0, you are also given AT curve is given, and at t equals 0, you are given its initial velocity v naught is 4 meter per second, and its initial position x naught is 20 meters given. So if that is so, you have to find what is x9 at 9 seconds, what is its position and what is its velocity, and also you have to plot vt graph and xt graph. So these are the things. So you have to find out what is the position at 9 seconds completed, what is its velocity, and also you have to find out what is the distance traveled and its displacement. What is the distance traveled and its displacement. So you should know what is the difference between distance traveled and the displacement. Distance traveled is the measurement along the path, right? Whereas displacement is what is the difference between the position at any given time interval, change in position. So at t is equal to 0, what is the position? At t is equal to 9 seconds, what is the position? The difference is what is displacement. But in that difference, it may happen that position might have changed, gone forward and come backward and so on. That we do not know. The path may be different, right? But the displacement is different. So that's what you should understand. This is a good example problem to understand this all. So what is that given AT graph is this? The given AT graph is this, that the equation A is function of time, and that's given by this 8 by 3 t minus 8. So that's given. Right, so you can plot now this straight line, and if you have A and you have to plot what is your Vt and what is your Xt, and also you have to find out what is the distance traveled from 0 to 9 seconds and the corresponding displacement. So this you finish it, and that this problem will be a good problem for you to have a lot of understanding. In case you do not follow, let me explain in the next class or post the solutions so that you can clarify. So with that note, let me stop today's class, and we will get into curvilinear motion, 2D motion, in the next class.
Sir, in exam, we have to draw this graph in graph paper.
In the examination,
We have to draw this graph in graph paper or what?
obviously, that's what I am teaching now. So you are expected to draw the way I have drawn and explained today. You cannot draw one adjacent to the other. I draw here AT curve and then VT curve on the right side, and then again on the right side XT curve. You should not draw like that. You should take scale and you should draw one below the other. So AT curve and VT curve and XT curve. So like that you have to draw neatly, and you should proceed the same way I have explained you. You will have in your FAT exam such kind of problems, right? So see here, XT, VT, AT, one below the other. So that is very sensible, and you should have such practice of plotting motion curves. That's called a primary motion curves here, and this curve here is secondary motion curve. So you may be given any one of the motion curve, and you will be asked to find out complete motion kinematics. That means you have to draw all the three. And you should also read the statement of the problem carefully to answer what is asked. Like that question that I had given you, what is the distance traveled and displacement from 0 to 9 seconds for the rigid vehicle which is undergoing rectilinear translation with an acceleration given by function of time 8 by 3t minus 8. That means that t is equal to 0, you have a is equal to. So how do you plot this? At t is equal to 0, a is equal to minus 8. So it is minus 8 here, say. At t equals, when a will be 0, when I mark a is equal to 0, and see this is t, linear variation. So when a is 0, t is at a equals 0, what is t? So t will be 8
3.
into 3 by 8. So it's 3. So at 3 seconds, it will be there. So I can plot this graph and extend it for a generic time t or till 9 seconds. So till 9 seconds. So what is a9? This 8 by 3 into 9 minus 8. So this is 3. It's 24 minus 8. This is 16 meter per second square. So this is 16 meters per second square. So I have drawn this. So you have to draw what is V9, what is V0, or V0 is given 4 meter per second. X0 is given 20 meters per second. But you see here it's linear variation, acceleration. So you will have velocity, parabolic variation. You will have position varying with the cubic variation. So if it is parabolic variation, you may have 2 points of velocity 0, right? And you'll have maximum value of that when its derivative equal to 0. That can be maximum or minimum value. So at t is equal to 3 seconds, you'll have velocity maximum in this case. And then you see velocity plot, you may have 2 points velocity 0, then you will have correspondingly 2 positions here p. So just you have to draw. And this is a generic problem. It's not a problem of uniformly accelerated motion. See here a is given as function of time, very important. So if you are understanding this, it's very generic. So if a is given as a parabolic variation or 2 degree polynomial given, then accordingly this become 3 degree and this become 4th order. So one order is more. So acceleration is of order n, then velocity will be of order n plus 1, and position variation will be order n plus 2. That's what you should understand, right? So with that note, let me stop today's class if there are no more doubts.
Sir.
Yeah.
Hello.
Yeah, tell me.
Sir, I just wanted to know about the 3 cat.
Yeah.